When we're talking about solving quadratics, we ordered some. When you're talking about solving and factoring here, the trick, I know that there are multiple ways to set these up. And what I want you guys to understand, there really is no wrong way of doing these things. The way that I set them up, though, is the same way every single time. Bless you.
I have a question. How did you go through the times table? Did you go in like rows? What is your thought?
All right.
Did you go in the box thing where you go this way?
Did you just scribble X? No. What I do is when I'm working on those, if you think about what you're doing the same thing in two different directions, right? So think going this way, rewrite it real fast. Think going this way, rewrite it real fast. Think going this way, rewrite it real fast. And you wind up going through, it's the most efficient way of doing it.
See, I was going through.
I felt like doing the square thing was very efficient.
That's what I did. I feel like it wouldn't.
All right, anyway, ladies and gentlemen, please, 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 please. As we get into these factoring things, I know that there are many ways to do this. I know some of you guys have done that box method with this lattice-looking crazy stuff, or whatever.
I love that way.
All right, if you want to do that way, that's fine. I don't even know how to even start that method. I've seen it a couple of times. When you get to a little bit of the upper level stuff, when you're going to start seeing maybe a fraction here or there, or when you start seeing some trig functions when we factor some of that stuff out, you're going to find that the method that I use, that T method.
There's a T method?
Yeah, just a little chart, little T chart. The way I do this stuff is the following. What times what is negative 28 that adds together to get negative 12? Basically, what are your factors of 28 that gives you a sum of negative 12? And then you start thinking about positives and negatives. Remember, if you're multiplying two numbers together to get a negative, one of them has to be negative, one has to be positive. But when you add them together to maintain it being negative, that tells you the larger of the two numbers should be negative. That's those kind of thought things I want you to go through. So as you're going through this, well, negative 28, well, let's see, that's 2 and 14.
Well, we got a winner.
We've got a winner right away. Which one's positive? Which one's negative? Negative 14. So when you go to write this in factored form, x plus 2, x minus 14. And that's the factored terms. Okay? Remember, if you need to double check this to see if you are correct, what do?
You set the x's equal to 0.
Foil. You foil. Good old-fashioned Billy binomial. You guys know Billy binomials? You don't know who Billy is?
No, teach me.
Oh, Billy binomial? Billy binomial is an important person. Billy binomial, you're right. Billy binomial comes about from FOIL. FOIL is first, outside, inside, last. It's Billy binomial.
It's giant. It like hangs out here. It's like this. It's ridiculous.
He's smirking.
What?
Mine's not very creative.
Same idea. What times what's negative 21? You add together to get positive 4. 7 and negative 3. Very good. X minus 7, x plus 3. Do you see why it's important to understand, remember your times table? That's the main reason I give you guys these things. To make your brain start going again. I was thinking zeros all of a sudden. Yes.
Yeah.
Sorry, I was thinking zeros off the top of my head. So that was the next question I was going to ask you guys. The next question I was going to ask you guys is, what happens to the problem when they throw this in then?
Now you got to set those equal to 0 too.
Correct. Then you're trying to find the zeros. Sometimes it's going to ask you to solve for zeros. Other times it's going to ask you just to factor. Remember, the only difference between the two is if you see an equal sign,
Just flipped it.
yeah, then you just set these both equals 0 to get -7 and 3. Those are your zeros. That's the intercept form that we graphed some stuff out of yesterday and going from there. Yes, sir?
Then do you have to do like a plus or minus and plug it back in to see if they work?
No, we're not there yet. We will do polynomial expansion where I'm going to give you guys the zeros and you have to give me a third degree polynomial. We'll get to that point, but we're not there yet. Okay? Don't worry, it's not that bad. I mean, for example, if I give you zeros, if I say the zeros of the function are -2 and 4, and it's a second degree, it's a quadratic, that means it's got an x squared then, okay? If these are your zeros, what would the terms be that gave you zeros of x minus 2 and x, or sorry, gives you zeros of -2 and 4?
+2 and -4.
-4.
And then you just FOIL out to get it to
So
that.
that's fine.
We'll get to that. Yes, sir.
We're gonna be doing the ones with the coefficient.
Of 1? Yeah, we'll get to those. I don't know if we'll do those today or not.
We'll do the one with Q.
We will, not yet. We'll get to those later. What times what's positive 28? Add together, get -11. -4 and negative. So you have x minus 7. Is this vaguely coming back to you? Remember, what I'm doing in my head here, and for most of these, when your leading term coefficient is just 1, it's relatively simple. You're asking what times what is positive 28 to give you a sum of -11. Since you have a positive multiply and a negative sum, both values are negative. Okay. Yeah.
Is there some way you can do this like with a formula?
There is a formula when you're talking about perfect squares, and there's a formula when you're dealing with sum of squares or terms of squares. All right. You know what? Let's. Well, take a look at here.
0 and negative.
What happens now? When you see only 2 terms, there's no b value here. Excuse me, your b value is 0, so there's no x term. What happens then is that you ask yourself the following questions. Is the first term a perfect square? Is x squared a perfect square?
Yeah.
Is 1 a perfect square?
No.
Is that a subtraction symbol?
Yeah.
If all 3 of those questions are yes, then you have what's called a difference of squares. So that means the first term is a perfect square, the last term is a perfect square, and the difference, well, that means subtraction. When that occurs, that's just x plus 1 and x minus 1. Does it matter which order you put that in? Nope. Not at all.
So would it be the same as, let's say it was x minus 4 or something like that?
It would be x squared minus 4, yeah. Like Wes is saying there, if you say x squared minus 4, if I'm going to factor that again, is x squared a perfect square?
Yes.
Is 4 a perfect square?
Yes.
Is that a subtraction symbol?
Yes.
So when you write that out, you get x plus 2, x minus 2. And it works the same way.
Okay.
Okay? That's what you call a difference of squares. It does not work with addition. I repeat, it does not work with addition. Can you say that after me? It does not work with addition. Repeat after me. Mommer is, no, sorry.
Is what?
I wasn't going to say that. That was mean.
Yeah, for real, guys.
He's a
I'm gonna
nice
say
guy.
I am a fantastic individual. I am
In your own mind.
the downgrade man.
Once again, what changes when you see the equal sign?
So you just gotta flip the sign.
Then you set them equal to 0 to get you're looking for your intercepts. Yes, ma'am. Hold on, what's that? What do you Why would you want to do that? That takes forever sometimes. there's nothing wrong with it. If you want to do that, that's fine, but just sometimes it takes so long. I mean, I'm looking at negative 30 to get to positive 1. 6 to 5. Yeah.
Oh, come on.
And it's one of those things. There are different methods that take less time or should take less time. So if you want to fall back on it, it's not the end of the world. But you also have to remember what you're solving for. If you're doing that without the equal sign, you're solving for the zeros. So you have to remember to replace those with the opposite. What times what's negative 30? You add together to get positive 1.
6 times 6.
So we have x plus 6, x minus 5. What are your zeros?
The answer is
Negative 6.
Where does it cross the x-axis?
Negative 6.
What's the axis of symmetry?
Negative.
x equals negative 6.
Negative 6. 1.
X equals 12.
What's the axis of symmetry on that one?
Negative 1 half.
Very good. Negative 1/2.
Oh, it's the middle.
And the last one. What times what's 9? You add together to get 10.
1 and 9.
1 and 9. Your zeros are negative 8 and negative 9.
Never mind. I was thinking it was minus.
Now, for fun, because I know you guys love this oh so much,
Oh, for sure.
No.
I might give you one of these or two of these just to see if you remember. We'll continue to go over this. You know what? No, I'll be a nice guy. Yeah, be a nice guy. Oh, you want to do this? All right. All right.
I don't know how.
Let's do one, and I'll give you maybe one to do for homework. Okay. For right now. When you're dealing with leading coefficients that are not equal to 1, the method that I use to do these by factoring is called factoring by grouping. I find that this method tends to be maybe like a step longer than some of the other methods, but it forces you to get the right answer, for lack of better terms. Here's what you do. What's 3 times 5? 15. What are your factors of positive 15 that add to get negative 8?
5 and 3.
Negative 3 and negative 5.
Negative 5 and negative 3. Do you agree?
Yes.
So here's what you do. What you're doing now is you might have heard this called split middle term.
Yeah.
Yeah.
It's the same idea as called factor by grouping. What I'm doing is I'm splitting this negative 8 into 2 terms. Well, 3x squared minus 3x minus 5x plus 5 equals 0. Because negative 3x minus 5x is negative 8x. Now I have 4 terms. What I'm doing from this point is I'm factoring out the greatest common factor. I'm doing the GCF twice. What's the GCF there? 3x.
Yeah.
Okay? Now, in order to make this work via grouping, I need to make that second term look like an x minus 1. In order to factor out the GCF here, to make it look like an x minus 1 in the term then, I have to factor out 5, but I have to factor out a negative 5. So if I factor out a negative 5, well, negative 5, or negative 5x divided by negative 5 is just x. 5 divided by negative 5 is negative 1. That forces me into having 2 of the same terms. Yes, sir?
So you divide each one by the GCF, right?
Yeah.
Okay.
And that's an easy way to see how you're getting that out of there.
Okay.
Because what you want to do, and I always love to give this example because this is the worst case scenario because you've got the double negative. What happens here, another way that people tend to remember, if you do it this way, by putting a plus minus, it reminds you to take the negative out. Sometimes people like to see it that way as well. We'll do more of this next week. I'm just giving you guys a little heads up here. But remember, when you're looking at these two guys, you have a GCF of 5, but you want it to look like the x minus 1. If that's a positive symbol, remember you have to take a negative out. So is x minus 1 and x minus 1, are those the same?
Yeah.
Write it down. What's left? 3x minus 5. And that's how I factor that. It is a little bit longer method than you guys might have seen in the past, but I like this method a lot. I really do. I think it's a very structured, straightforward method to it. But there is one last thing here. Everybody see how it says equals 0, right?
Yeah.
I heard you say it. The 0 for this one is 1, and the other one is 5/3. Is everybody okay with that? Add 5, divide by 3. And so on. Not so bad? Let me give you guys a couple of problems to look at. Can I steal someone's book?
You said 1.
Actually, I'll give you one of the coefficient sets.
Do we have to grab today?
All right? Bless you. All right. I think we figured out how the windows are going to break.
Nah.
So this is 5.
Did we ever find out how the windows are gonna break?
I have not gotten an email back from the company yet, but I was told that they called the manufacturer, and the manufacturer said that they did not want to release the information of the breaking points because they didn't want to be liable.
Did you tell them you were
Yeah.
Did you tell them it was for safety concerns of the students of the children of ages 13 Wait, they're probably not here. Tell them that it's a house
Probably should
It's
start.
not just the
No, you just need like a square certificate so that all it's because you want to
All right, do those, please. No, 36 and I should and comma 40.
Do it.
You know, you could always just bring a chainsaw or a sledgehammer.
I'm just move this over so I can stop where we're at real quick.
Wait,
I have all study hall. I have nothing.